Good afternoon, class. Today we're going to be working with web APIs. So that is a application programming interface that is hosted on the web. In this case, we're going to be working with the Jokes API, which is available at jokes.one. And I picked this particular one because it has a really good suite of documentation, and it's a really good example of just a basic API that supports both fetching data and sending data. So we're going to play with all of those. Like I said, it has very good documentation, so it has examples in multiple different programming languages you can take a look at of how to actually make a request, as well as telling you exactly what format that response you're going to get back is going to come in. And what they support is JSON, XML, and JSON-P. Today we're going to look at JSON, which is JavaScript Object Notation. This is the way of serializing JavaScript objects that has really become the de facto standard for exchanging data on the web. And XML, which is an older standard that was used for the same and is still used for the same purpose, exchanging data on the web. You'll also notice this looks very familiar, very similar to the HTML and the XAML that you have been using, and that's because those both were built on top of the XML standard, so they actually are an extension of the XML approach. Now, this is a RESTful API, so they're following the REST approach. So like all REST APIs, there's the URL that we're going to visit, and then we have specific combinations of a resource route and the HTTP verb to access that, which actually defines what we're going to do. So for example, if we use the HTTP GET request against the /JOD, we're asking for the current joke of the day. And that's where we're going to start. We're going to actually create an application that's going to fetch that and then print the current joke of the day to the console. And this is going to be just a standard, straightforward console application. You've seen this code is what's automatically generated when we create a new .NET Core 5.0 console application. So it should be very straightforward and very similar. Now, in order to fetch data from the web, we need to have a way of doing that, and in C#, one of the best ways of doing that is, or simplest ways, is to use the web request object defined in the system.net namespace. So that's exactly what we're going to do, and that class represents a request to a web server, and then will actually package and give us back the response. So we're going to go ahead and create a web request object. And you might be thinking, well, we're creating an object, so we need to call its constructor. And in most cases that would be true. However, with the web request, if we go and take a look at the documentation, it will tell us quite clearly that the constructor is obsolete. And the reason is they want us to actually use a factory method called create. And what this does is we'll create a new web request based on what URI we provide to it. So here we're going to go ahead and call web request.create, and we need to give it that URI, which is going to come from our Jokes API. So we're going to go ahead and pull this URI. And we also want the route, so JOD for joke of the day. And this is going to, this factory method will actually look at this and figure out what protocol we're going to use. So it looks and says, oh, we're using HTTPS. So it's going to create a version of web request, so basically a object derived from web request that is specifically for making HTTPS requests. So the object we're getting here is actually not truly just a web request, but it's a class derived from a web request. But we can treat it just like any other web request object because it inherits from that. So this is kind of the very basic piece of creating something to represent that request. And then we can add different metadata to it, and we'll look at that in a moment. But once we've created it and we've got it set up the way we want, then we send that request off and get a response. And that response is a web response object. And we get that by, again, sending this request. So we'll say request.getResponse to send our stream of data to the server, which is going to hopefully respond to us and send data back, which is going to populate this response object. Now that data coming in is going to be a stream, just like when you open a file and start reading it, you're reading a stream. When we push data across the internet, we're actually sending a stream. So the .NET platform and C# treat those as streams as well. So anytime we want to use a stream, we know it's in the system .io namespace, and okay, stream response stream, and we can get that stream from our response object with get response stream. Pretty straightforward. Now there is something we should be aware of when we're using a stream like this, is this stream is actually created for us from the operating system. And this is a resource that is managed by the OS and not by the .NET platform, which means it's an unmanaged resource. And what we mean by unmanaged is just that it uses some operating system stuff that we need to tell explicitly, we're done with that operating system, you can take it back. And how we do that in C# is an object like a stream is going to implement the iDisposable interface. And that interface just says it has to have a dispose method, and when you call that dispose method, that tells the object how to let go of all the things that it has that are unmanaged. And we have some special syntax to go with that, which is a using statement. So what that looks like is this. We say using and then parentheses stream response dot get response stream. So the response stream is going to be stored in this object, which is going to exist for the scope, which is why we have the curly braces. And then once we end this scope, .NET and C#, the actual platform, is going to automatically call that dispose method and get rid of it. And the nice thing about this is that will happen if there's any errors that occur in our code while it's being processed within the scope, or if everything goes successfully. So this replaces the need for adding a try catch to catch any possible exceptions and then throwing finally on that. So this just ensures that we release those resources properly, no matter how our actual processing of that stream goes. And of course, processing a stream is one of the things that we can occasionally run into errors with when the network goes down, if we get disconnected from the internet. Those are all reasons that response stream might get interrupted or not give us the full value, or it might get corrupted along the way as it's being streamed across the internet. There's a lot of things that could potentially go wrong. So it's good to have that little bit of protection there. So this using is called a using statement. That is different than a using declaration, which is what we're using up here. So different ways of using the using keyword. All right, that response stream, if we want to see what that is, we can use something like a stream reader object to actually read the stream. Let's call it reader, new stream reader, and you've probably done this with files when you opened a file on stream. There is several methods for doing that. And then we're going to go ahead and call, in this case, create a string. I'm going to call this temp reader.read to end. So that's just going to read in the entire stream, put it in that temporary variable, and then we're going to log that to the console. Console.tmp. And if we go ahead and run this now, we should make a GET request against this address and pull in that stream, read it to the end, and spit out what that's going to look like. So let's go ahead and run this. And there you can see we have success, total 1, contents, jokes, and this is clearly JSON. So this is the JSON format that we're talking about. Now, what if we wanted to have an XML format? So it defaults to JSON. Let's say we want that to actually be XML. Well, the way we can do that is we can modify this request to say, hey, server, please send us a XML version of this. And how we do that is with a header. So there are a number of headers that are part of making a request, as well as a number of headers that belong specifically to a response. And the header that we use to actually request a specific kind of data is the accepts header. And that just says, this is what I accept. And it can be more than one thing. In this case, we just want to have application slash XML, and that application XML is what we call a MIME type. That's multimedia encoding. It's a standard way of identifying a particular kind of document or file or stream of data. So in this case, we're saying this is XML. Some of the other ones you might have seen is text JavaScript, text HTML. So in this case, we're saying, please give us this data as XML. And if we go ahead and run that now, notice our response is now XML data. So we can very easily ask it to send us different types of data. So let's go ahead and look at the XML version of that response. So if we come down and look at the response data here, notice we have a response. Inside that we have a success tag and a contents tag. And inside the contents we have a jokes, which potentially could contain multiple jokes. Notice that it has some background information on the joke itself, and then the actual joke tag with the information in it. And what we really want is this, the text of the joke. That's really, at this point, all we care about. So let's see, how can we pull that information out of that XML document and get that available to us? Well, we're going to be using another namespace. So using system.xml, and we're going to create, in this case, I'm going to comment these guys out for the moment because we're not going to be using them. Instead, we're going to switch to an XML document approach. And XML document is a class that exists in that namespace, which represents an XML document. And we can construct it with a traditional constructor. So this is not using a factory method. And then we can load into that object the XML we want to actually use. And notice there's a lot of overrides, but the first one is a stream. We could also load from a file, from a text reader, from an XML reader, a lot of options. But we have a stream, this response stream, so we can just load it directly from the response stream. That's going to load up into this xdoc object the contents. It's going to parse that XML stream and basically give us a way of talking to it. And XML, we can actually navigate using something called XPath, which is a way of going through the structure and saying, I want to look at a specific part of this. And each of those is actually an XML node. So each one of these tags is a node. So we have a response, it has a child success and a child contents. So if we wanted to look at the contents, we could say look in response / contents, and that's the XPath to get down there. And it has a lot of interesting ways you can tweak it, just like the CSS selectors that you've been working with in the web assignments, where you can actually look for a specific attribute on one of those nodes and things like that. We're just going to use the very simple way of doing it. So we're going to navigate down to a specific node by querying our document, calling select single node, and providing a string, which is that XPath. So we said if we start at the root, so we do a first initial slash, and then we want to start drilling our way down through that document. So response is the first thing we're going to look at, first node, and then we're going to look in its child of contents. And then its child of jokes, and then its child of joke. And then in the joke, we are going to look at text. Now, Select single node is going to select the first node whose XPath matches this. And depending on how you're using this API, there's only one joke if we're using the joke of the day. But if we're using one of the other routes, there'll actually potentially be multiple jokes. So this would only match the very first joke and only grab the very first joke's text. So that's just something to be aware of. And now that we have that node, we can look at its contents with its inner text. Which is going to be all the stuff within the tag, so the actual text of the joke. And we can log that with console.writeLine node.innerText. So if we run this now, we should grab that same joke, but at this point we'll only print the joke itself. And you see here, what do you say to Santa when he's taking attendance at school? A present. So there we have our joke of the day. Now, one of the other things we need to be very aware of when we use an API is there is often some rules about how you're allowed to use that. And in this particular example, notice that it tells us you are required to credit jokes.1 if you are using the free version, which is exactly what we are doing. So we need to also have some kind of message letting people know where that joke is coming from, just to be in agreement with their requirements. Okay, but what if we wanted to use JSON? So let's go ahead and tweak this a little bit, and we're going to make this a JSON request now. Well, that means we're not going to process it as an XML document. So we're going to comment this out. And now we need to parse a JSON request. And C# has a library for doing that. And system.text JSON. Now, this is a fairly new system library that was added to C# around the time that .NET Core 5.0 was launched. So if you go searching for this on the internet, if you search for JSON in C#, most likely you're going to get a response about JSON.NET, which is a third-party library that is actually a very mature and a very good JSON parsing library, but it's not the one that comes with the system libraries. So this is one that can really trip people up because a lot of the help documentation you can find online as far as tutorials and things is really referring to a different library that's similar but not the same as the Microsoft implementation. So be sure that you're looking at the right suite of guides if you're using one versus the other. And the nice thing about using this one is we don't need to pull in any NuGet packages. With JSON.NET, we have to pull in a NuGet package, and we have some external dependencies to be aware of. And just like we have an XML document in the JSON or the system.text.json namespace, there is a JSON document representing a document of JSON. And it does not have a load method. Instead, when you construct it, it expects, if it would show me the details on the constructor, it's going to expect a string to be passed in. And for some reason, it's not going to tell me what it's actually expecting. Oh, sorry. Let me back up. That's not how we get a JSON document. We actually get a JSON document by calling a JSON serializer, which is a static class, and call its deserialize method. And this, notice we have a lot of overrides. We can either pass in a JSON string or a reader, which is a UTF-8 JSON reader, or a read-only span, or a JSON string again, or UTF-8 JSON reader, or a read-only span. So we really need a string as the easiest way to do this. So we're going to uncomment our stream reader and get our temporary string again by reading to the end, and we'll just pass this in. And that should be the string that we're expecting to get back out. And then there is a templated version of this method which allows us to say what kind of object we want to deserialize into. So it is possible to actually deserialize directly into a .NET object. You have to write a C# object that corresponds to the object that you're actually looking at, or you can use the generic JSON document object to say, I just want to parse it into this JSON document, which is, like I said, an object representing a JSON document. And then it represents the key value pairs that exist in the JSON. So if we go back and look at the JSON format here, this is the actual start of the object. We have the key success maps to this object, which contains a property of total, which is key maps to this one. And the same thing, we can have jokes, for example, maps to an array of objects. So you can kind of think of JSON as a dictionary of key value pairs, where the key is a string and the value actually can be an integer, it can be a boolean, it can be a double, it can be a complex object, it can be an array, it can be all sorts of things. And how they actually represent that in this JSON package that we get from Microsoft is with JSON element objects, which can be any one of those things. They're kind of a polymorphic object, if you will. So the JDoc itself has a root element which represents it, or is the very first of those dictionary objects that we're talking about, the JSON element. And the JSON element has a get property method which we provide a key to. And so in this case, contents, which is the very first key that we're interested in, and it's going to return a JSON element that represents all of this. So it's basically going to deserialize it and turn it into a object representation that contains a property for jokes and no other, well, copyright is not inside the, yeah, it is in contents, so also copyright. So you're going to get those two pieces. And then we can drill down because what we really want is the jokes. But if we look at our syntax here, notice that jokes is this array. So we're going to get jokes from that. JDoc, or not JDoc now. Now we're looking at the contents element. Get property. Jokes. And then that jokes object, like we said, is an array. So the next level down would be an individual object within that joke array. And notice that there's no key here, it's just an object. And then inside of that we have the key joke that we care about. So this object is not actually the joke, but it's actually like a wrapper around the joke. So we have this metadata plus the joke. So let's call that joke wrapper. And we get that from jokes. And because jokes is treated as an array, we can actually access it using the array accessor and say that we want element 0, so the very first joke that's in there. And then the joke itself is going to be that joke wrapper.getProperty joke. So we just have to drill down far enough into to get to the actual object we're after. And then the joke itself has a text property, which is the actual text of the joke. And once we get to that point, we should be able to log to the console our joke text. And that should be a string coming out of that because that's what's actually stored. Now notice it's going to actually determine what these are. Basically at runtime, this get property is going to evaluate and hand back the right object for what it actually is. And there we have this same joke shows up because this is joke of the day and we're still on the same day. So we'll get the same joke. And we might also want to add the copyright date, which we can pull out of this joke wrapper layer, or if we're using X document, we could select that particular node and pull out its inner text. That would be a good thing to do, as well as crediting jokes.1 to actually also acknowledge when the copyright date is for that particular object. But that's the core of accessing an API.